All right, so we'll go over these questions together, and I would say these are some questions that will be quite similar to what you will see tomorrow. Okay, now the way I break it down would be to label these questions by flavors. Okay, so you are getting different tastes basically on these trig equations. So I would say flavor number one is taking square root. Okay, and what do we need to know when we do square roots? You got to make sure that you have the positive and negative, right? So so you would have cosine square x equals to 3/4, and when you do the square root, you would have positive √3/2, or cosine of x is equal to negative √3/2. Okay. So that's the first thing. I want to make sure that you understand the flavor here. All right, so got the square root kind of flavor. So make sure that you acknowledge that you have two possibilities. And based on these two possibilities, you write out your angles. And as I said, it's all about your unit circles. All right, so cosine x is equal to √3/2. That means your angles are pi/6 and 11 pi/6. And then for the negative, it will be quadrants 2 and quadrants 3. So we've got 5 pi/6 and 7 pi/6. All right, so got to have these angles. All right. Comments, questions? Easy? Okay, so whenever you see the need of square roots, make sure that you will consider the positive and negative square roots. All right, the second flavor is to make sure you can factor these are quadratic expressions. And as I said in class, I hope you don't need to use dummy variables in this case. So 2 cosine x times cosine x will give you 2 cosine square x. And then you got 3 and 1. So it seems like this would give you a -5, because when you do the outside, you get -6 cosine x. When you do the inside, it will give you plus cosine x. So -6 cosine x plus cosine x would give you -5 cosine x. So how ready are you to process the FOIL process? Okay, to visualize the FOIL process mentally, and then verify that it is the correct combination. And once we have these two parentheses, we can go ahead and write down our two possibilities, because each one of them could be 0. So we say cosine x could be -1/2, and cosine x minus 3, huh? I think we talked about this before. Cosine x can only be up to 1, right? So in this case, we got nothing. Okay, we got nothing from the from cosine x minus 3, because there won't be any x value that could ever make this part of the statement true. Okay, never ever. So then we will just go ahead and consider the cosine x equals to -1/2, which will give you angles from quadrant 2 and quadrant 3. So you've got 2 pi/3, and then you also have 4 pi/3. Okay, 2 pi/3 and 4 pi/3. So these are your answers. Okay, so just simple factoring. Make sure you know that you can factor. That's very important. That's flavor number 2. Flavor number 3, yes. 2 pi/3 and 4 pi/3. Quadrants 2 and quadrants 3. All right. Now the third flavor, Okay, it's just simple factoring. And I put a little parentheses, don't overthink it, because guessing some of you might be looking at this and we're like, wait, hold on. I remember something like this. Do we change it? We said, no, we don't need to, because if you can just see that, well, you got sine x for both terms. So all you need to do is to factor the sine x, and you have something like this, and this is very, very easy to process. I'm not saying you cannot change 2 sine x cosine x to sine of 2x. You could, but then it just doesn't get you anywhere further. All right, so you have this. So you have sine x equals to 0, or 2 cosine x plus 1 is equal to 0. So sine x equal to 0, x is 0 and pi. 2 cosine x plus 1 is equal to 0. That means cosine x is equal to -1/2. So x is equal to quadrants 2 and quadrants 3. I think it's just like the previous question. 2 pi over 3, and then 4 pi over 3. Okay, 2 pi over 3, 4 pi over 3, and then 0 and pi. So you got a total of 4 answers. Okay. Next up, okay, I got flavor number 4. Okay, I call this resist the temptation to divide. Factor, factor, factor. Now, why do I say you have to resist the temptation? Because for most people, they look at the tangent x on the left, tangent x on the right, they're like, let's divide. And this is where you need to learn and need to understand why we don't divide, by the way. Why don't we divide? Why can't we divide? Why shouldn't we divide? Yeah, so if you finish it, you will see that tangent x will equal to 0. And if you divide it, then you are effectively eliminating some solutions out of the question. So that's why we do not divide them. Okay, and so whenever you see something like this, again, your mind could be urging you to divide, and you're like, nope, thanks for the reminder, but no thanks. Let's go ahead, move things to one side, and then you will just factor it. Okay, and this is how you have to have 2 steps ahead, that kind of thinking. You got to process the factoring mentally, and you say, oh, I think I can see something. I can see this is going to happen. You're just going to say, oh, I can also see this happening as well. If you don't process the mental math, then it's kind of hard to justify why you would subtract the tangent x to the left. All right, so again, if you divide tangent x, this thing will not exist, this thing will not exist, and you are eliminating 2 major solutions. So tangent x equal to 0, that means x must be 0 or pi. On the right-hand side, we have 3 tangent square x minus 1 equal to 0. So tangent square x, it's 1/3, and tangent x, it's 1 over square root of 3. So so you can also think about tangent x being √3 over 3. So x is equal to, that will be quadrants 1 and quadrants 3. This will be pi over 6 and 7 pi over 6. Okay. Yes. Oh, yes, we do, actually. We do. Thank you. So we do have the take care of the negative as well. So then you have a negative √3 over 3. And then x would be 5 pi over 6. And then we got 11 pi over 6. Thank you. Thank you. All right. So that's the flavor number what? For the previous one here. Okay. So again, do not divide out the whole function. Okay, that's a very, very tempting thing to do, but don't do it. Okay, next one. That's your number 9. We say we have to adjust the domain when needed. So the domain for the original domain is 0 to 2 pi, but we now have 2x. So that means our domain will go all the way up to 4 pi for 2x. So we would say 2x is equal to, well, -3. That would be quadrants 2 and quadrants 4. That would be 2 pi over 3 and 5 pi over 3. Now that's only up to 2 pi. But we now have to go all the way to 4 pi. So we just have to make one full revolution, okay? Meaning that we have to add 2 pi, or since we have a denominator of 3, so we're going to add 6 pi over 3, okay, onto these guys right here. So that's how we have h pi over 3 and then 11 pi over 3 for our angles up to the 4 pi restriction. And dividing 2 on both sides, or multiplying by 1/2 on both sides. So you now have 2 pi over 6, 5 pi over 6, 8 pi over 6, 11 pi over 6. And since you see some of the even numbers, you want to cancel them out. So so that's just pi over 3. That's just 4 pi over 3. Okay. So so you have these answers: pi over 3, 5 pi over 3, 4 pi over 3, and then no, sorry, pi over 3, 5 pi over 6, 4 pi over 3, and then 11 pi over 6. Okay, so make sure when you see something like 2x, 3x, 4x, you have to adjust the domain accordingly so that you can get all the solutions. Okay. All right. So then the question number 11. Make sure they speak the same language. Okay. What I mean by same language is that you can see here, that's a sine square x. That's a cosine x. Well, sometimes we can sometimes we can factor, but for this one, you just can't do anything. But we learned something before. You remember that sine square x is equal to something else? We say, well, yeah, it's 1 minus cosine square x. So you can do 2 times 1 minus cosine square x, cosine x plus 1. So you have 2 minus 2 cosine square x, cosine x plus 1. And I would say, let's go ahead and move everything to the right-hand side so that I can have a positive 2 cosine square x. And then you combine like terms, so you have a -1. Okay, after you subtracting 2 on both sides. And that's how you know this is the right step to go with, because now you can factor. Again, if you can't see the 2 steps ahead, it's kind of hard to tell yourself, to justify your own work. So 2 cosine x squared, 2 cosine square x is 2 cosine x times cosine x. So you have 1 times 1 equals to 1. So that's how you factor it. That's the only way you can factor it. So now you have the 2 possibilities: 2 cosine of x minus 1 equals 0. And cosine of x plus 1 equals to 0. So cosine x equals to 1/2. Cosine x equals to -1. And just go ahead and get the angles. Okay. So that's what I mean by speaking the same language. Okay. So if they have some significant difference that prohibits you from moving further, then you know what you could do, which is to make use of all those Pythagorean identities, okay, so that you can move the sine function to the cosine function, and now you can factor. Because if not, you can't really have anything done without changing the sine square x to 1 minus cosine square x. Okay. All right, now the next one, finding all values of x. Speaking of which, I realized yesterday after making the video, if you watched the video that I uploaded yesterday, for question number 18, I forgot that it was supposed to be all values. So I forgot to tag on the 2 pi k at the end. But well, let's go ahead and look at this together. So we have secant x equals to 2. And as you know, I don't like secant, so I'm going to go ahead and change this to cosine x equals to 1/2. Just do the reciprocal. So x is equal to pi over 3. And x could also equal to 5 pi over 3. That's just from 0 to 2 pi, but we want all values. So we just tack on 2k pi or 2 pi k, whichever one you prefer, to tell everybody that, hey, doesn't matter how many revolutions you have, as long as you end with the same position, you got the same cosine x equals to 1/2. Okay. So to make sure that you understand what it means by being asked, find all values of x. Okay. And then the next one I said flavor 7.1, basically the same thing, but we have to adjust the domain a little bit. So first, let's just consider that it's 0 to 2 pi, that kind of situation first. Okay, so with 2x, you will expand the domain to 4 pi. So for the moment, it's only for the moment, so that we can find out all of the solutions for our first revolution. So we say 2x is equal to, that will be quadrants 3 and quadrants 4. That would be what? Over 4, 5 pi over 4. And then we have 7 pi over 4. And then we'll keep going. And we'll say we add 8 pi over 4 towards these terms. So we have 13 pi over 4. And then we have 15 pi over 4. And then our x would become 5 pi over 8, 7 pi over 8, 13 pi over 8, and then 15 pi over 8. So the first thing that you do is to do it as if you are doing just your regular ones on the front page from 0 to 2 pi. And then afterwards, since it's for all values, you just tack on 2k pi for all of them. Okay, so that would take care of all values. That would take care of all values. Okay, yes. 2 times, yes, because we are like from From here to here, it's 0 to 2 pi. And here to here, it's 2 pi to 4 pi. So, so that will take care of all the possibilities. Second? Yeah, because if it's 3x, that means you have to go all the way up to 6 pi. So that's why. Okay.